We're about to dive into what might just be the biggest question anyone can ask. What is reality? Right now, at the very edge of physics, a huge debate is raging over whether our universe is all there is or just a tiny piece of something much, much bigger.
And I think this question from Stephen Hawking just nails it. We've got these incredible equations that describe our universe with stunning accuracy. But they're just descriptions. They don't tell us why we have this particular universe with these particular rules in the first place. What lit the fuse?
For the longest time, reality seemed pretty simple, right? It was the stuff we could touch, see, and measure. But the deeper physicists and philosophers go, the more you realize that the fundamental nature of everything might be stranger than we could have ever imagined.
Okay, so one of the biggest puzzles that gets this whole debate started is this. Our universe seems perfectly, almost suspiciously, fine-tuned for life. The basic forces of nature, things like gravity, if you tweak them even a tiny, tiny bit, you wouldn't get galaxies, stars, or us. You'd get nothing.
So, how do we explain this incredible cosmic luck? Well, physicist Bernard Carr uses this great analogy. Yeah, winning the lottery is ridiculously unlikely. But if you do win, you shouldn't be surprised that you exist to collect the prize. That's the core of the anthropic principle. Of course, our universe looks perfect for us. If it wasn't, we wouldn't be around to notice.
But let's really think about that lottery analogy for a second. It only works if a ton of other people bought tickets and lost. And that simple, logical step is what cracks open the door to some of the most radical, reality-bending ideas in all of science.
So that one little thought experiment leads us to three huge and pretty controversial ideas that try to explain our lucky universe by suggesting it's not so special after all.
First up, the big one you've probably heard of, the multiverse. And look, this isn't just something out of science fiction. It's actually a natural consequence of some of our best theories, like cosmological inflation, which describes the explosive growth of our universe right after the Big Bang. That process might not have just happened once.
And this is a fantastic way to picture it. In some models, new universes are constantly popping into existence, like bubbles in a vast cosmic foam. Each bubble could have totally different laws of physics. If there are trillions upon trillions of them, well, it's not so surprising that at least one, ours, got the recipe for life just right.
Okay, now for a more abstract idea. It's called the mathematical universe hypothesis. It argues that the deep reason math works so well to describe our universe is because the universe itself is math. It's not just that a particle has properties like charge and spin. The particle literally is those mathematical properties. According to this view, our physics theories aren't just math that approximates a physical world. Nope, they're simpler mathematical structures that are approximating a much more complex underlying mathematical reality. The idea is that all possible mathematical structures exist as their own universes, and we just happen to live in one that's complex enough to be self-aware.
And finally, we get to the third big possibility, and this one is a real trip, the simulation hypothesis. This suggests our entire reality, everything you see, everything you are, is just an incredibly advanced computer simulation built by some higher intelligence. The argument is pretty simple. If it's possible to create conscious simulations, then it's likely that countless simulations will be created. Statistically, it's way more probable that we're in one of the many simulations than in the one original base reality.
So, bubble universes, realities made of math, cosmic simulations. You can probably guess that these ideas have kicked off a massive debate about where exactly we draw the line between science and pure speculation. And one of the leading critics is physicist George Ellis. And he really doesn't hold back. For him, this isn't just an academic squabble. He believes that by even entertaining these ideas, we risk undermining the very foundation of what makes science so powerful.
And this really gets to the heart of the conflict. On the one hand, these theories offer this beautiful, elegant explanation for that fine-tuning problem. But on the other hand, well, how do you ever test them? If a theory can't be proven wrong, is it even science? A theory that explains everything might actually explain nothing at all. And that's Ellis's big point, and it's a powerful one. By their very definition, these other places, these other universes, or the computer our simulation is running on, are completely cut off from us. We can't get a signal from them, we can't do an experiment. So how can we ever know if they're real?
Now, to really wrap our heads around this clash between a good story and good science, let's borrow a really cool idea from psychology. It's called the argument from error.
and it's a way to find the hidden, flawed assumptions in how we think.
The core idea is this. When people make the same mistake over and over, it's not just random. It actually reveals a kind of faulty but consistent naive theory they're using in their heads to make sense of the world.
Here's the classic example. Imagine you see an inner tube shoot out of a spiral water slide. What path does it take into the pool? A lot of people will draw a curved path, as if the tube remembers the spiral. That consistent mistake shows they're using a flawed intuitive idea of impetus, a kind of lingering force, instead of the real physics of momentum.
Okay, so let's bring this back to our big cosmic debate. What if the fact that all of these grand theories are consistently, systematically untestable is their impetus error? Could it be the clue that we're applying our scientific models to questions they're just not built to answer, a fundamental flaw in the whole approach? But there's another way to look at this whole thing. Maybe it's not a flaw. Maybe what we're seeing is just the next step in how science itself evolves, by constantly redrawing its own map of reality.
I mean, just look at the history of science. Our map of the cosmos has just kept getting bigger and bigger. We thought Earth was the center, then the sun. Then we learned our whole galaxy was just one of billions. Every step of the way, people said, this is crazy. So asking if our universe is just one of many, it feels like the next mind-boggling step in that same journey.
And check out this prediction from the philosopher Auguste Comte back in 1842. He declared with total confidence that we would never be able to figure out what stars are made of. Just a few years later, the invention of spectroscopy made it possible, and now it's a cornerstone of astrophysics. The impossible became routine.
So, what's the takeaway here? It's that the line between what we call physics and what we call philosophy isn't set in stone. It moves. What seems like untestable speculation today might just be the standard textbook science of tomorrow, waiting for the right tool or the right idea.
And this brings us to what might be the real point of this whole spectacular debate. As Bernard Carr puts it so well, maybe the biggest discovery here isn't about the nature of the universe, but about the nature of science itself. These moments force us to ask the hard questions. What are the limits of science? What counts as evidence? And just how far can we push our methods before they break? That, in itself, is a profound discovery.